Hello, my name is Davin, and I teach astronomy at the Boonshoft Museum of Discovery in the University of Cincinnati. Today we're going to talk about the solar system, but not the big planets and sun that you may be used to hearing about. We're going to focus on the little bits, the minor bodies of the solar system that include the asteroids, comets, and even the many icy bodies that reside in the far out regions of the solar system in places called the Kuiper Belt and the Oort cloud. As it turns out, the solar system's smaller objects are super fascinating and are important relics of what our solar system was like when it first formed 5 billion years ago. By studying what these little guys are made out of, their shapes, where they are now, we can learn a lot about how the solar system formed and the Earth in almost unimaginably distant time in the past. So, using our spaceship of the imagination, our view is curved here so we can see more of what's around us. Let's move away from the Earth and position ourselves where we can get a good overhead look at the solar system. From this vantage point, the planets shine like points of light, like stars, from the reflected light of the sun. Here we see the orbits of the planets. You can see how clustered they are closer to the Sun, Mercury, Venus, Earth, and Mars, the terrestrial planets, and how widely separated the planets are, starting with Jupiter, Saturn, Uranus, and Neptune. Let's start with the asteroid belt, particularly the main asteroid belt. So what you're going to see here in a minute is an accurate representation of all the orbits of thousands, hundreds of thousands of lumpy, rocky bodies that we know that reside in between the orbits of Mars and Jupiter. The true number of asteroids in the belt is surely in the millions, and they range from sizes from hundreds of kilometers, essentially mini planets, to tiny dust-sized particles. Contrary to what you may have seen in Star Wars or Star Trek, the asteroid belt is mostly empty space. The population of asteroids is separated by vast distances, and it would almost be impossible for you to hit another asteroid unless you were deliberately aiming for it. While it might be tempting to think of the asteroid belt as a result of a planet that was destroyed at some point, from careful analysis of what the asteroids are made of, it appears that this is not the case. This is leftover debris from the beginnings of the solar system, the stuff that didn't form into planets, albeit broken apart in some cases over time, herded into an area by billions of years of gravitational tugs and pulls from the sun and planets. If you were to add up all the mass of the asteroid belt, it would only add up to less than 4% of our moon's mass. So there's very little stuff out here. What are these asteroids made out of? As it turns out, they can be a combination of materials, and that's the way we classify them actually. C-type for those that are carbon-rich, and they dominate the asteroid belt's outer regions and comprise over 3/4 of all the asteroids that we can see from Earth. S-type asteroids, or silicate asteroids, are heavy in silicates, and some metal too, but no heavy carbon compounds. And these are about 17% of the asteroids in the belt. M-type asteroids, which are rich in metals like nickel and iron, these may have been part of the cores of protoplanets or other larger asteroids, where metal sunk to the core of those bodies when they were molten. So there's the main asteroid we saw earlier in white, the main asteroid belt, I should say. But there's more to the asteroid belt than just that. On the outer edges, there are families of these asteroids, like these blue asteroids right here in these sections. These are called Trojan asteroids, and they're actually in the orbit of Jupiter. They're just behind and just front of Jupiter as it goes around the sun. These are gravitationally stable places called Lagrange points, where many things that find their way there will stay there for quite some time and not be swept up by Jupiter's or the sun's gravity. There are as many asteroids in these two Trojan groups as there are in the entire asteroid belt. Getting closer in, as you can see, there are many other families of asteroids: the Hungaria family, the Phocae family, and even further out, the Hilda family. The last group has what's called a 3-to-2 orbital resonance with Jupiter, which means these asteroids reside in orbit that makes it go around the Sun 3 times for every 2 times Jupiter goes around the Sun. You can see the movement of every individual asteroid that we know of here and their orbits around the Sun through the computations of our Digistar's planetarium technology. There are other asteroids too, by the way, not just in the belt. There just aren't as many as of those. The Apollo asteroids, for instance, are a group of about 10,000 bodies that reside near the Earth, in orbits that cross our home planet's orbit. So if you're worried about if these asteroids can hit the Earth at some point, well, there's good news and there's bad news about that. The good news is that we've cataloged the bulk of the largest ones, and none of them are slated to hit the Earth anytime soon. But the bad news is that due to gravitational effects, this could change, and we don't know about all the small ones yet. In fact, one of the small ones did hit the Earth in 2013 over Russia, causing damage over the town where it exploded high above the town, smashing windows and damaging buildings. So let's zoom farther out here so we can see the next family of very different minor objects in the solar system. As we do, I do want to point out Ceres right in the center there, which is the largest asteroid in the solar system. It's right there in the asteroid belt. It was actually called a planet for long after it was discovered. But it's spherical. It's pretty big. It's almost 1,000 kilometers in diameter, and we know that there's bubbling salt water coming up from the surface of that. But anyway, out here beyond Neptune, 30 times farther away from the Sun as the Earth is, begins the dark, cold realm of a family of icy bodies scattered across the depths of interplanetary space to all the way to 50 times distance from the Earth to the Sun. So 30 AUs, astronomical units, to 50 astronomical units. These are the leftover bits from the formation of the solar system, made of a combination of rock and ice. The remaining bits out here are relatively small accumulations of rock and ice, not quite as big as a planet, but some of them can be quite substantial. We call them Kuiper Belt objects, named after the astronomer Gerard Kuiper. Many of these are large enough to be considered minor planets. The most famous Kuiper Belt object is Pluto, considered a planet until 2006, after evidence mounted that objects similar to Pluto, and just as large, such as the dwarf planet Eris, existed out here, and so it was designated a dwarf planet instead. But most of the suspected 100,000 objects out here are relatively small, 100 kilometers or more in diameter. Let's pull out even farther to the edge of the solar system. Out here is another family of icy bodies, trillions of them, that are suspected to be slumbering out here. This is the Oort cloud, named after astronomer Jan Oort, who predicted its existence. This is the farthest debris field left over from the solar system's formation, and it forms a spherical-like shape around us, starting between 2,000 and 5,000 astronomical units, to as far as 50,000 astronomical units, almost a light year distant. Once these icy bodies gets ever so slightly pushed one way or the other by gravity, they can hurtle toward the Sun in highly elliptical orbits. As they near the Sun, they heat up, their ice turns into gas, leaving long trails of gas and materials behind them. In other words, a comet. We see these comets as sunlight reflects off their bright tails and nucleus as they head toward the Sun. And if they survive the hot trip, heading back outward. Halley's Comet might be the most famous comet. The last bright comet we could see for the naked eye was Comet Hale-Bopp in the 1990s. Humans got a great close-up of a comet several years ago as the European spacecraft Rosetta and its lander Philae flew up to the comet, much as we are now. The probe took amazing close-ups and images of the surface. As it did, its probe, which landed on the surface, also took great measurements before being disabled after bouncing off the surface into a shadow where it couldn't recharge its solar panels. Comets are a great place to end our journey. They can put on a spectacular show for the inner solar system, showing off the pristine ice and dust from the solar system's birthday, kind of like a fireworks show billions of years in the making. Thanks for watching. Stay tuned to the Boonshoff Museum of Discovery and the Carroll D. Phillips Space Theater for more journeys into the universe around you.